Welcome back, 5th period. We're going to pick up where we left off on this problem. This is the bearing problem where we were trying to find the bearing that the Julia would have to take to return to Oak Harbor. If you don't remember, Oak Harbor is located here. So the point we had gotten to, we had discussed how if this angle here is 57 degrees, which we had found from our previous problem, then this angle here would also have to be 57 degrees. What we're looking for is the complete bearing. So let's draw a picture of what we're looking for from here all the way to there. Now we know that to this point here, this is 270 degrees. So all we need is that little bitty part there. In order to get this little bitty part, what we need to do is find the angle inside the triangle we have here and subtract it from that 57. So the red arc here that I'm trying to find is the 57 minus this green angle. So let's solve for the green angle. We can use law of sines for this. We can say sine of the angle that we want, you can call anything you want to, over 2 is equal to, the other arc measure we had was here. This was 71 degrees, and we got that from the 33 and the 38 here. The 33 plus the 38 gave us that 71, so it would be sine of 71 over the value we just solved for in A, which is 3.85. We cross multiply and solve, and we get theta is approximately 27.5 degrees. Okay, so we know that this green angle is 27.5 degrees. So if we do the 57 minus the 27.5, we are left with that little bitty red angle that we wanted, and that one is, 27.5 degrees. I'm sorry, this was 29. And what we're left with for the red angle is 27.5 degrees. So how could we write our answer? One simple way would be to say this is 27.5 degrees north of west. Or we could take that 270 and add it back and get a bearing of 297.5 degrees. Okay, what I'm going to do now is talk you through the next problem. It is worked out here for us, so let's discuss what we're looking at. It says an airplane leaves the airport and travels due east for 30 minutes, traveling 200 miles per hour. So this line here is going to represent due east. This is the first part of our trip. Well, if we travel for half an hour at 200 miles per hour, we've gone a total distance of 100 miles. That's where the 100 came from. Then we change direction and travel at a bearing of 35. So if you think of this as your north and this is your bearing of 35, and then we're traveling 200 miles in that direction. That's where that 200 comes from. Here's my north, my bearing of 35, and then I go 200 miles in that direction. Then the first thing we're asked to do is find how far the plane is from the airport. So what we're looking for is this side of the triangle. So we've got these two sides. I need that included angle. Well, this has got to be 90 degrees here, and the 90 plus the 35 gives us an angle measure of 125 here. So to find this 270.1, what I did was a squared plus b squared equals 2a cosine of c. Plugged in the 100, the 200, and plugged in the cosine of 125, and got that this distance is approximately 270.1 miles. All right, the next part B, what bearing should the plane travel to return to the airport? And in 6th period, we discussed how this would be a very tricky angle for a commercial airline to make, but let's go ahead and answer the problem here. To answer this, we can simply use law of sines. Start with what we know both of now. Sine of 125 over 271 is equal to sine of what we're trying to find out, theta over 100. So this angle inside the triangle is 17.65. Well, that's not what I'm looking for. I'm looking for the bearing. So to find the bearing from this position, I need to go back to that parallel lines cut by transversal. If this has a measure of 35, then this must also. So this is 35 degrees. So we are 35 plus the 17.5 past the 180 degree mark. Or we could say we are 52.65 degrees west of south. Or you could take and add this to the 180 and say we're at a bearing of 232.65. Either answer is acceptable. And we will continue working on these tomorrow.